Hello everybody, welcome to the online session of Econstruct. So online and offline, of course, because here also there are so many offline students are there. So today we are going to see certain things about the shear force and bending moment diagram. Simple things, but sometimes it is very complicated for certain students. So for that, it becomes actually the entry barrier for certain students. Why? Because you know interstory drift ratio, you know soil structure interaction, but you do not know about the shear force bending moment diagram of a simply supported beam. क्यों उल्लू बना रहा है मुझे, like that sometimes it happens. So what I'm trying to suggest you is small things should not become an entry barriers for you. For that reason, this session has been taken. Okay, simple things. Sometimes some people they make complicated, but we try to make it as simple as possible so that it is very convenient for you guys to work around it. So shear force and bending moment diagram, what is all this? What is shear force, what is bending moment diagram? And I'm not going to teach you the simplest formulas and all actually which were there in the college days, that okay, you take the summation of Fy equal to 0, summation of Fx equal to 0, and the summation of the bending moment diagram is equal to 0. But I'm going to show you a few things that how you can do it basically in the ETABS for this kind of small problems. And yes, manual calculation, I'll not go again back to the theory because my principle is practical to theory, not theory to the practical. Okay. So few things uh, how you can manage by using the software. Let's get started with this, and small portal analysis and other things how you can manage to do it. Okay, to do that, we have started working with one of the prototype assignments and all are there. I'll just explain you. So yes, I hope many of you can look into the screen. And here you can see that there are certain questions and all are there, so that you can go through that and solve this kind of questions through the manual calculations and all. This is not a manual calculation session. We are going to arrange a special session for that if you really want to do it manually, how you can do it. But this is basically in the ETABS actually not only like this, but small, and this is a truss analogy. But small shear force bending moment diagram, how you can solve it. Okay, so I would like to just open the ETABS and just say the new model and just start working with, let's say, the grids only option. Okay, so in this kind of cases, you can do the, let's say, the 8-meter grid is there. So 16 meter. If, let's say, for example, if there is a continuous beam from here to here, and at some places there are supports, this support, and on this there is a load given to you, let's say 10 kilonewton meter per meter, which is under the gravitational load. And if you analyze it, how the bending moment shape will be there. So let's say over here, I'll just store this file. And only for this, what is the shear force bending moment diagram? So let's say I'll just go to the first of all bending moment diagram like this over here. I will show you in the elevation part, which is like this. So over here, what are the values are there? So you can just click this button so that you will get the values at this particular place. Just hover it, you will right click it and you will see that there are values over here. So these are the deflection, these are the bending moment values and the deflection values. I'll just so you can see these values. Yes. Okay, so these are the values of the shear force and bending moment that you will be seeing it over. Okay. Now, few more things I just wanted to tell you that what are the things that you will be seeing it here. Basically. Whenever there is a maximum shear force and bending moment diagram, you need to find out. So this is basically the equivalent loads. Equivalent loads or equivalent load diagram. In other words, it is basically the problem statement that okay, here there is a support, here there is a support, and this is the load coming on this with certain values given here. This is a problem statement and this is the analysis statement. Understood? And for what particular load case, or sometimes currently I am not given the combinations. So if you want to see the combinations, or you might require to go to the modal cases also. So that is this particular figure over here. Coming to the next, you will see that there is a I, J and a particular length also would be there. What is IJ? IJ is, this is I, starting point is I, end point is always the J. So at the beginning of this particular beam, what is the shear force over here? Because the shear force, as you know, that it is the maximum at the edges. So how do you calculate? How do you get the values? You will see it here. Bending moment diagram, as you know that it will be maximum at the center, which is sagging, and it is maximum at the edges, which is for hogging, which is for top steel for the fixed beam. The deflection will be always measured in such kind of beams, it will be maximum at the center. So you'll see that what is the maximum absolute, this is basically the relative values with respect to the beam. Means here the value of the deflection is 0. With respect to this, how much is this value coming here? That is this particular value. This is the absolute value, global value. Means the entire build, the structure is also going down. So how much is this particular value if you click it? Generally speaking, this is relative to the frame. You know that there is a portal frame analysis. So in the frame, if you right click this particular beam, then what happens? How much the frame is also going down, actual shortening of this particular column. Pertaining to that, how much is the beam is also going down over here. That will be shown if you are clicking this option. Like that, many other options also would be there. So what I'm requesting you is go through the such kind of options. If you scroll it, you can scroll the mouse and check it, how much is the bending moment. Okay, many a times I have identified that the shear force and bending moment diagram, it becomes an entry barrier for us, any structural engineer which is there going to go for an interview for any of the company. For that, we will give you, let's say, 100 projects, 100 different type of, 100 also may not be required. Maybe 10 different projects will give you, in which the simple diagrams and techniques would be there. Okay, because every company, if you go, they will ask you first question, shear force bending moment diagram. because that will take you to the basic structural engineering level, basic, very, very basic. That what is the shear force bending moment? If you do not solve such kind of small examples, there is no point in solving 50-story building. That's what actually the judgment the employer will put you. That he will put that impression on him about you. So how to solve this kind of puzzle, this kind of things. So in one ETABS file, you will have all the 100 projects also if you want to see that. There is a this software is that capable that you need not create 100 EDB files in your file. If you are creating, there is an advantage for that also. That is up to you. As well as you can deal with this kind of problems in one particular project only. You can have multiple problems there. So let us see how you can do that and how you can solve this puzzle. So let's say in one project you are having this as a continuous beam, correct, with the supports here. So what I'll do is I'll go to the 3D and I'll copy this file. I'm going to unlock this and I'll copy this file where I should copy minus y areas. Copy means the replicate function. So I'm going to replicate this to minus 8 meter here, maybe 3 times. So you know that the one problem, it has become the two problems here. So here I'm going to make the release. So there is no support here. So this will act like a cantilever. In this case, I'm going to delete these two supports. So this full will be act like a beam. This is like a simply supported beam. And here I'm going to give this as a fixed beam. And these two cases, let's say I would like to make this a little bit more complicated. This is no support. This is overhang, correct, and there is no support. So this is just the UZ, whereas this is the fixed support here, and there is a cantilever here. Now, problem is one only. End conditions have changed. Span is same. Understood? So how many beams you can create in one file? So let's say I'll just save this. I'll run the analysis. And after running the analysis, we'll get to see the results. Now, let us see the results. These are the results over here. What you can do in such kind of cases is you can create another window, more window. So let's say I'll create this as total frame number 1, 2, 3, 4, like that. You can generate it. So this is the one. This is the second option. Okay. This is the third option. This is the fourth option. So 1, 2, this is 3. This one is 4. See, as I told you earlier also, I generally like to make complicated things simple. So that exactly I'm trying to make it out here. So this is the beam where it is. This is the edge which is cantilever. You can easily point it out. This is also cantilever here. Here I given one support here so that you can see that there are certain changes. These are coming here. This is like WL square by 8. So obviously the center span bending moment will be higher. And this is the normal continuous beams with the pin support at the base. So how many problem statements you can deal with something like this? How many you can think? You can do millions. No problem about it. With a simple logical understanding that grid 1 you are having this, grid 2 you are having it, one problem statement. Try to figure it out. This is one of the very big opportunity for you. Why? Because any company, if you go, the first question will ask on this. Or maybe there would be a written test where there will be 4 5 minimum few large amount of problem statement would be there on this. So I have identified that problem previously also, that many people are knowing the interstory drift calculations, they know the finite element basis, they know the performance based designs, they know many things, but they do not know how to solve this kind of small problems. So this is the answer to that. This is not to crack just the interview rounds, but this will help you in understanding that where is the hogging bending moment, sagging bending moment, where are the basically the shear force and how it is really working. Because the moment you understood that, you know, how it is working in many places, you will get to know that, oh, this is how the shear force diagram will work. The shapes, the values, yes, those things will come over the period of time, but at least the shape. I still remember the very first interview which I given in Pune. They have asked me the shear force bending moment and deflection diagrams only. No values required, only the shape. Understood? So all of you are requested over here that to work on this kind of principle, that okay, you go ahead with this, you create millions of, or maybe at least initially hundreds of such examples. You take one small problem statement and you complicate it as much as possible. Okay, you bending over here, there, and you try to first of all get familiarized with you regarding the shape of the bending moment diagram, not the value. How the cantilever behavior will happen, how the continuous behavior will happen, how the simply supported behavior will happen. Now, suppose this is the same case, I want to see that as a fixed beam. Just unlock the model, take these two elements or the select these two joints, and now I am giving this as a fixed. Now you'll see it was a yellow color diagram like this. Now you'll see that some of the other case also it will be bending moment diagram will come like this. Understood? So at such kind of places, you will see that you need some kind of top steel here and the bottom steel also you need to have it. Got it? And such things will come where you are having column here and column here, or maybe shear wall here and shear wall here. And the beam going like this. So that time you'll realize that you require the top steel here and the bottom steel. Okay, so this is basically for the concept design also. For some of you guys to crack certain interviews, it is very important. Some students are, those are recently given the exams, they are also probably watching this. So those students also, because the moment you go to any company, this is the first question even I will ask, to understand the basic fundamental question, understanding about the shape of the bending moment. Shape, shape, no values. Now this is basically for an individual element. Now let us further complicate this to create that as a frame element. So how do you do that? So I'll add the same thing to the other floor. This can be single file. We'll copy the same file as what we call it as the portal frame PF. And I'll just copy this to all other floors. And the moment if I go to the plan, and I would like to give all this as the columns here because these are the columns. So let's say, for example, select all the slabs and beams and giving them as particular RC column. Even if you give this beam, it doesn't create any kind of difference. Rather, I'll create this because these are all okay. So what I did is again I'll go back to this portion. Now you'll see that the support conditions are exactly dot to dot. Those are same. Yeah, the column has come only up to first level, so I just select it and I would like to delete those, or maybe I'll copy that to all other floors. And then wherever the columns are not there, initially the support conditions were not there, that places I will give that as there are no columns. There are columns here, yes. Every grids will check. So grid number this one. And here also there is no column, so I'll delete this also. Here there is a column. Here there is a column. Yeah, here there are no columns. So I'm going to delete this. So if such kind of cases with the and I would like to delete all the support conditions except the base. How do I do that? Just select this entire thing. Assign the constraints as 0. You go to the base and the base we leave that as a fixer by selecting a single floor. And then we can go to individual floor to see that how it is happening. Maybe in even the 3D. Now let's run the analysis. Now this is portal frame, same function, but the portal frame analysis. Understood? Now how do you study this? So let's say over here, how the shear force bending moments to section 1, 3, 4. So this is, I'll take this as a 2. So every place, previously what it was, shear force bending moment diagram It was there for just the continuous beams or simply supported beams. Now it is there for the total frame. Is it difficult to calculate? So today you are going to study only the shape, how the shape of the bending moment diagram and the shear force diagrams. Sometimes they will say that I will be adding the horizontal force here. Only the horizontal force. What is the shear force bending? What is the shape? Not the values. Understood? The moment you have cleared that exam, the next level exam would be given to you. What are the values? So you need a calculator or something like this because the total frame analysis requires the vigorous, you know, analysis. Actually, you cannot just arrive at certain figures just like that. That also will take some small examples and because it will become the entry barrier for later on. Understood? But once the tool is there with you, it is very simple. That one thing you need to cautiously understand in your mindset. Do you agree? Hmm? Now, the moment if I say that this is the value and all, but where are the loads? I have given certain loads, 10 kilonewton per meter. In that also you will see that there are self-weight. So if you want to calculate only, please understand this very carefully. Okay, what is it? Because everywhere I given the values, which is like this. This is the load value it is given. But apart from this load value, there is one more value, what we call it as, what is this? Self-weight multiplier as 1. Self-weight multiplier 1 means what? The self-weight is there. Understood? Huh? So the UDL is also coming plus the self-weight of the beam is also there. So the values will not match. Why? Because people are going to give you the value like this. This is, let's say, 10 kilonewton per meter. This is, let's say, 5 meter. This is 2 meter. Tell me the force here. Let's say RARB or FAFB. What is the force? What is the moment? So let's say these are the A and B points only. So at the A and B point, what is happening? Just tell me. So here it is only load. Where is the self-weight of this column, this B, where it is? वो तो आएगा ना, वो तो पॉकेट में थोड़ी ना वो लोड कैलकुलेट करके दे देगा, तो लोड है. That value will not be coming right, correct? Why? Because the self-weight value is 1 here. So this value you need to make it 0 so that uska indigenous kuch load इसमें नहीं है. I mean, the individual load of the column and beam will not be hindering the problem statement of yours. Understood? Okay, I'm just sorry to. Okay. So how do we calculate all this? How do we get along with all this? How to check the values? How to check first of all? First, पहले तो shape चाहिए, then the values will come. If the shape itself is not right, value will be never right. Value is even more complex. Value is more complex. So how do you get along with all this? Okay. So value is the impression of the plus, minus, and the because it is finite. Uh, I mean, if you see that it is in some equations will be indeterminate structure. There are determinate structures and indeterminate structure. What are determinate means the value is perfectly right. Value is perfectly right, and the another value is value will be near to right. Limit extends to 0. Means it is not exactly 0. It is nearer to 0. Maybe 1 into 10 raised to minus 6 is 0. It means like that. Understood? Hmm? So you will be giving certain determinate structures majorly during the that few days. Sometimes the structure will be given it as an indeterminate structures. When you will not come to know the exact values. So you will have to go for different methods. Actually, what are the methods? Yes, very good. So Chinese method, slope and deflection method, moment distribution method, stiffness matrix. Understood. So certain methods you need to at least, I'm not saying all the methods, but at least one of the method you should be conversant into it. Because all methods are you use the Casio calculator or you use the Excel or maybe you can use certain MATLAB program. But answers would be near to the same. Some differences are okay. To certain moment, yes, certain small differences are acceptable. Understood? But I'll tell you, in each and every area, this becomes the entry barrier, even if you are topper in our class. If you do not know how to solve this, is that very clear? Many play people they get selected just like that after looking at the portfolio and all. That is a different matter. But almost like 70 to 80 percentage people they ask you the shear force bending moment. The moment they ask you, if you do not know how to solve this kind of, let's say there is a cantilever shape here. So how the cantilever behavior that will happen over here. So this is the full cantilever. You can see that over here. That this is the full cantilever, and this moment is getting distributed to here, and certain moments is distributed here, and it is going here, and again it is going here. So if impact of this is there at this particular span plus this span. Understood? So how do you solve this kind of things actually? I mean, if there is a slope and deflection method or moment distribution method or something. So one or two methods will not show you all the things because it is already done. I mean, पूरा गन्ना बस निकाल के बाजू में पड़ा है. So we'll not go to that deep level. Are you getting what I'm saying? But the basic level, so that any Tom, Dick and Harry will not tell you, अरे तुम तो 50 माले का बिल्डिंग दिखा है ये साला शेयर फोर्स बिल्डिंग में मालूम नहीं उल्लू बनाता है. Understood? So coming to the small point, like imagine that Tesla का मोटर बना रहा है but नट बोल्ट डालने को नहीं आता उसको बॉनेट खोलने को नहीं आता. So small things also might test you in the initial phase and might hamper you also. Oh my God! I mean, there are some people. Believe me, when we were actually back testing our modules of trainings and all, actually, we have identified those kind of lacunas. बंदे को सब मालूम है. I mean, we never come across this kind of situation at all in the industry, at all. So I don't generally, yeah, I generally check that some small thing, basic things are known or not known. But I generally do not go that deep कि slope and deflection में गन लगा के ये problem solve करके दिखाओ. No, we don't do that because it never comes actually. I might tell him or somebody that okay, this is my building. You at least model it and show me that within 24 hours what maximum you can do it for me. So if he can perform one day till the expectation of me, I can have it. And that really makes sense. So such kind of problem statement will be given to you also, which you are very well trained anyway at the end of the course. But this problem statement would be very difficult to some of you guys because we never come across this kind of situation. Point number one. And second point is you lost the touch with this kind of things before. Am I right? अभी आपको
Yes,
मैं
sir.
this calculation I tell you ये calculation करके दिखाओ. Then it would be very difficult situation for you. Okay. So we'll see it both ways. One is through the software based also and through the manual calculation also. We will not touch the manual calculation immediately because it will be too boring for you. I would suggest, I would request rather, I would propose you guys to solve. Don't go too much deep into the subject. Just go to certain reference books and copy certain problems and solve it over here. Does it make sense, everybody? Hmm? Instead of I teach you slope and deflection method or this method, that method, you go through the best of the best books and get certain good problems. I would suggest each one of you maybe minimum 5 problems. And don't go to next बाजू वाले रूम में जाके तुमने क्या किया थोड़ा सा वैल्यू चेंज करके. Don't do that. Let's do it sincerely. So let's say this guy is, what's your name? Govardhan. So Govardhan has created 5 projects. Small. These are also project, right? Project 1, 2, 3, 4. These are also project. This is first project, second project, third project, fourth project. This is for online students also. So you guys also come across with certain problems like this. Okay, so each student minimum 5 problems. Okay, one is initially you do it manually or you do it with the certain reference books, but you understand how it has been done. You should be able to replicate it properly. And that problem statement you do it in the ETABS. Is that okay? So we'll call it as annexure SFD BMD and deflection diagram. All three of this. Okay. What is the annexure name as? SFD BMD and deflection diagram. Initially simply supported. What is the value? Bending moment. 25. WL square by 8. Understood. And shear force how much? 25, 25. Understood. So we will go with the very basic problem statement so that it doesn't create too much of stress over here. I'll tell you very honestly, within these 7 months of the whatever the course that we are dealing with, the moment you see that there is a pressure, pressure cooker, the moment you understand there is a pressure cooker here, you consider that certain things I'm going wrong, and you should just flag it up to us. Do you agree? The moment you understand that some pressure is coming to me, because it should go very smoothly. Our training programs, all our, we are so expert in, some people will not be able to, just you need to be attentive, that's it, and do whatever it has been said, slowly focused, that's it. Okay, so will you bring all these things? I will give you 2 weeks time, more than enough. So this is Monday here, not coming Monday, next Monday, next to next Monday. Let's have the deadline. और आपके जो प्रोजेक्ट प्लानर है ट्रिक्स में इधर उधर उसके अंदर डाल दो ये. So it will be there on 23rd, sorry, 13th of December. Is that okay? And you are going to present it to me. Present means, say, sir, this is the problem. This is how it has been calculated manually, and this is how it has been calculated in the ETABS. Is that okay? Yes. This way it will help you 2 cases. Okay, 5 problems. In the 5 problems, I mean, if you are solving more than 5, I'll be more glad. Okay, 5 प्रॉब्लम तो ऐसे 2 घंटे में हो जाएंगे, 2 हफ्ते क्यों चाहिए, correct? But I'm asking you to work at least 2 complicated problems. So don't take simply supported or something. This is very simple, childish. Nobody will ask you this. The major criteria is basically for you to understand 2 will be the determinate problems, and 3 will be indeterminate problems, the total frames. Is that okay? Indeterminate, total frames. And at least another 2 if you can solve with this trust related will be great help. This I'm going to give you before the end of today's day. All these problems, how many are there? 15 are there. So all these 15 you will be solving. This is basically for the trust. इसमें कुछ नहीं है. A में reaction कितना है, B में कितना है और बीच में कितना है. That's what they will be asking. Angle, how much is the angle, how much is this, how much is that, all these things will be there. So this you are going to solve it manually. This is constant, you need not search which one is what. Okay, and if you guys are facing the problem, it's 2 weeks. So 5 examples which I told you continuously, and the portal frame is different than this. Okay, these are 15 examples, whatever the number of examples are there. These examples you will be solving manually as well as software. Is that okay? If you want software, it will be by evening, it will be ready. Maybe within another 4 or 5 hours, it will be ready. But I'm giving you another 2 weeks is basically for you to solve it through the manual. Okay. If you want to do the groups work also, it is okay. So some people are knowing how to do that, and another people are studying it. It is okay. But end of the day, you should be able to solve all the problems. So on the upcoming Monday, there will be a small test will be given to you, including all these 3 things. Is that okay? So we'll be presenting it here one by one, and I'll give you a small question paper so that you can solve it. So once for all, shear force bending moment diagram will be swaha, finished. Is that okay? Sounds good? Yes. Everybody? Yes, sir. And I am giving 2 weeks. Believe me, 2 हफ्ते में हम लोग सारे बीटेक का फाइनल ईयर फिनिश करते थे. It is a very luxury time. Okay, we'll go very slow, cool, calm, and silent, but we'll clear all the things. So almost I'll tell you 20 to 25% of the work which was there in your interview, it is clear. And this is a part of your portfolio. Means imagine that tomorrow there is a interview, just go through that portfolio, whatever the things which you are writing, it is created by you only, so you need not mug up. Understood? Online students also? Yes. So whatever the things which you guys are doing, it is a part of your portfolio. So at the end of the session, you need not again struggle and rework. So let's start working with that. Got it? Any questions anybody want to ask? And yes, do not use too many different methods. I want to use the stiffness matrix method also. I want to use slope and deflection method also. I want to use this method, that method. Do not complicate it. If you are having calculator, just do the hand calculation and finish it up. What we are interested in the results. Do you agree? At the end of the day, are you going to use the slope and deflection method? No, you are going to use the software like StatPro, ETABS, SAFE, SAP 2000 to solve my projects. You are not going to use slope and deflection or or moment distribution methods. Okay, this is basically for you to understand how does it work, how the forces are getting transferred. Understood? So you work on only one method, whichever you like. If you feel that no, I want to use stiffness matrix method, which I'm sure that many of you may not be, because that is complicated matrix method. Okay, but whatever the method that you will be using, use only one method. Otherwise, jack of all, master of none. No. सब कुछ आता है, लेकिन सर ये this factor I forgot. or this matrix I solved it wrong. I have forgot this matrix. No, don't do that. You solve only one method, whichever method you like. Is that okay? Fine. So I think yes. Is there any doubt in the online session also? Please let me know.
Sir, in giving frames in assign,
Yeah.
hello, in assign in frame object, sir, there is an option called output station. What is that, sir?
Okay. So yeah, Abu Sufyan is asking the question. There is a problems about there is an option here. One
Output
minute, I have
station.
to unlock the model for that. So there is an option called output number of output stations. This is the option he's asking for. Okay. अभी ये output station क्या है? So generally it is three. What is three? Three is basically by default ये तीन है. It means I would like to show you because showing is believing. I'll run the analysis and I would like to show you the shear force and bending moment diagram here. One minute. Is this bending moment diagram visible? Yes.
Yes, sir.
I'll try to make it bigger so that everybody can watch. Now, this bending moment diagram is there, and I would like to design this also. Oh, all beams are failing. You know why all beams are failing? Because the section size is very small. I modeled it by because see instead of just this, I'll tell you. Top three and bottom three figures are coming. That's what it means. Station size means let's say here top one, let's say T1, T2, T3, and B1, B2, B3. What is T1, T2, T3? This is the top stage at the three junctions 1, 2, and 3, and the bottom three. This is the bottom stage at the three junctions B1, B2, B3. That is what it is. If you want to increase, generally in the RCDC software, whenever you are exporting this file, you need to export it so many, I think more than some 23 or 24 times. You require, I'm not sure exactly the number, I'm forgetting it now. But numbers of readings are required more so that to understand till what actually require the extra top stage here or the bottom stage. So the number of output stations you will not change unless and until you wanted to export it to the software called RCDC. This is very SCube company has developed this software. It's very useful software. I'm sure that it could be helpful for you. Okay. Any other question?
We don't have to increase the mode if we are not importing that into RCDC.
You don't need to do anything that. If you want to use only ETABS and let's say uh, safe or maybe ETABS safe and AutoCAD. So why you need to complicate the things? Correct, no?
Okay,
Yes.
okay, sir.
You'll use top three, bottom three. 50 bar, I mean, if there are some 20 readings on the top and 20 readings on the bottom, you'll figure it out what the hell is happening. पता ही नहीं चलेगा कि कैसे to figure it out. So yeah, assignment this is for you guys also online students. हाँ, ऐसे मत रखो कि यार मेरा तो हो गया, मैं तो जॉब कर रहा हूँ अभी, मैं तो पढ़ाई कर रहा हूँ। अब अगर आप पढ़ाई कर रहे हो, ऐसा नहीं कि एवरेस्ट पे जा रहे हो, ऐसा नहीं है। ठीक है, तो ये असाइनमेंट सबको करनी है, 2 हफ्ते का टाइम दिया है। 2 हफ्ते में पूरा बी सिविल निकल जाता है, ये एसएफडी बीएमडी क्या चीज है ना? करेक्ट है ना? Okay. नहीं तो एंट्री बैरियर बनेगा बॉस, मैं कुछ क्वेश्चन पेपर दे देता हूँ, सॉल्व करके दे दीजिए।
Sir, may you
मैं
suggest
टॉप
any?
टॉप कंपनीज में एंट्री बैरियर हो जाता है। It will become an entry barrier for you. Entry barrier means you cannot get inside it. There is a lock. इसका चाबी ये है, SFD BMD। करेक्ट है ना? तो पढ़ना जरूरी है।
Sir, may you suggest any good book for analysis of
Pardon?
structures? May you suggest any good book for analysis of structures?
You are good. You guys are better than me in that. कौन सी बुक जरूरी अच्छी है, गूगल पे डालेंगे, ये करेंगे। You are good at that. I'm not good at that. I'm not a bookish person. I'm a practical person. बुक वगैरह वो प्रोफेसर लोगों को पूछ लो, वगैरह वो अच्छे बताएंगे। I'm not good at that. हाँ, रामामृतम ये वो अभी नाम ही याद है, बुक बोलेंगे कौन से कलर का है वो भी याद नहीं। हाँ, बीसी पुन्निया, कम से कम 3-4 लोग बुक राइटर भी इसी हॉल में आके गए हैं, ये रूम में। हाँ, और वो ये कोर्स भी करके गए हैं। फिर नाम नहीं लेता उनका, नहीं तो फिर वो ऑनलाइन वाले भी देख रहे हैं यहाँ पे, लेकिन वो यहाँ पे आके गए हैं और ये बोल के भी गए हैं कि हम लोग वही काम करते हैं, अलग अलग कॉम्बिनेशन में खाली। हाँ, ट्रिक करके क्लीन बोल्ड करना, बस इतने काम है उनका। तो इट इज नॉट अ वेरी हाई फंडा थिंग, जस्ट अ स्मॉल हर्डल। अब जाते जाते सामने पत्थर है, उसको लांग के जाना है, नहीं तो उसका हवा नहीं बनाओ। एसएफडी बीएमडी इज अ सिंपल थिंग, यू जस्ट नीड टू पास दैट। इज दैट ओके? फर्स्ट इज शेप। अब शेप अच्छी तरह से देखेंगे। इफ देयर इज सम स्मॉल चेंज दैट हैज हैपेंड इन द calculation, if certain thing, if you by mistake, if you have forgotten few things, at least the shape you have identified it right. So shape को 50% mark है, 50%, then the values. Okay, if the shape is not right, then the conceptual level only is not, then you will definitely not get selected. But if the shape is right and then values are slightly not correct, then it is okay, then it goes to the next question. The moment you go to the next question, you are cleared that, am I right? पासिंग मार्क्स हो गए, स्कोर नहीं किए लेकिन पास तो हो गए। ये एक ट्रिक है, ट्रिक करके वो पहले वो समझ लो, ठीक है ना? okay. देखो, तीन इंटरव्यू में तीनों जगह पे फेल हो गया है, ये तुम्हारा ट्रेनर है, करेक्ट है ना? और एक जगह पे है, मैं उसका नाम भी लूंगा, यहाँ पे एल&टी कंपनी में है, मेरे को दे टोल्ड दैट मोर देन 55,000 आई विल नॉट पे द सैलरी। बाद में पता चल गया उसका ही उतना सैलरी था। तो he has given me the shares option, shares यानी कंपनी के shares, they will be giving it to me, but I will not be able to sell the shares for the next 3 years. That was the bond, ठीक है? That option also was very good option. Okay, it was my urge to start my own business and all. Okay, that's the reason, but it was a good option for you also. Okay. One more thing, I do not know, I should not be announcing it, but we are working on that front actually. We are planning to start one of the office abroad, actually, maybe somewhere in the Middle East. Okay, but the students who really want to do some kind of internships and all, actually, it may not be happen immediately. It will take around maybe 6 to 8 months, actually minimum, but we are working on that. So we can give that kind of chance also, possibly. Not sure 100%, maybe 10% only we have started working since last. because of this pandemic and all, we dropped the idea because before that we started working on that, but we dropped the idea. But hopefully we will do that. But again, 2 दिन पहले ही मैंने वो कौन सा और एक वेरिएंट आया है ऐसे सुना, तो होपफुली ऐसा कुछ याद नहीं आ जाए, नहीं तो फिर वापस वो प्रॉब्लम. But we are working on that. Our students might get a chance that at least they will get the visa and you can stay somewhere else and you can also work on the certain projects and find the job there in abroad. तो एक बहुत अच्छी फैसिलिटी आप लोगों को मिल सकती है. ओके, सो थैंक यू सो मच एवरीबॉडी. यस, एनी अदर डाउट ऑनलाइन गाइस? सारे लोग करेंगे ना?
Yes, sir.
Yes, sir.
Okay, so please keep this thing on the deadline. I will also tell you. Going to start. Thank you so much, and we'll see you tomorrow, same time, same place. Bye.
Thank you.
Thank you,
Thank
sir.
you, sir.
Thank you, sir.